Chapter 10 Implementation Support Exercise 10.1 In contrasting the red evaluation loop and the notification-based paradigms for interactive program, constructive of the preemptive dialogue was discussed. How would programmers describe preemptive dialogue by purely graphical means? Answer: Creating a preemptive dialogue by graphical means is quite simple. In a graphical-based interaction, it is assumed that the user can only interact with parts of the system that are visible. In a Windows system, for example, the user can only direct input to a single currently selected window, and the only means of changing the selected window would be by indicating with some gesture within that windows. To create a preemptive dialog, the system can produce a window which covers the entire screen and make it the currently selected window. A user input will be directed to the window and the user will have means of selecting another window. The covering window thus preempts any other user action except that which it is defined to support. Exercise 10.2 Recall the state transition diagram for font characteristic present in the Chapter 8, Section 8.3.3. Compare different interaction objects with the code. Implement this kind of dialog. Use example for existing toolkits, pull-down menu, or dialog box, or create a novel interaction object. Answer: The recall of the example, we want to allow the user to toggle between three font characteristics: bold, italic, and underline. Pull-down menu and dialog box are the most frequently used method for implement such a dialog. A pull-down menu would have the three choice list with some way of indication whether the characteristic was active or not. Upon its invocation of the menu, the user could change the active status of one font characteristic. For example, they could turn on the bold filter or turn off the underline filter. The important filter of the dialog is the more complex task. Changing the active status of the two or more font characteristics can only be achieved by separate invocation of the menu, and often the only way the user can check the status will be by popping up the menu again without invoking any action. This last point shows that menu design alone does not support immediately display of relevant state changes discussed in Chapter 4 under the syntactability principle. Within a dialog box, the user can effect several changes at one invocation. Technically, it's not a dialog box interaction device which allows for this, but the use of toggle button. Its font characteristic is represented by a box which acts as a simple on-off switch of the characteristic. As an aid the user, the toggle button can change its interaction. Can change its appearance so the user can know the status on or off by looking at it. A similar interaction widget in the checkbox, which will be labeled with the particular font characteristic. Clicking on the checkbox will put a mark in the box to indicate that the characteristic is on. Another click will remove the mark. In fact, a dialog box needs to be used to portray as a single of the toggle button or checkbox, as they could be presented continually so that the user can always view the current font characteristics setting. The reason a dialog box might be used is because there might be many font characteristics to choose from, and the dialog box will keep the group together and preserve screen space by allowing them to be hidden and used on an as-needed basis. Exercise 10.3 Scrolling is an effective means of browsing through a document in the Windows that is too small to show the whole document. Compare and different interactive behavior of the following two interaction objects to implement scrolling. A scroll bar attached to the side of the window with a arrow at the top and the button. When the mouse is positioned over the arrow at the top of the screen, which point up, the window frame is moved upward to reveal a part of the document above before what is currently viewed. When the bottom arrow is selected, the frame moves down to reveal the document below after the current view. The document is contained in a textual interaction object. Pressing the mouse button in the text object allows you to drag the document within the Windows boundaries. You drag up to browse down in the document and you drag down to browse up. The difference between the two situations can be characteristic by noticing that in the first case, the user is actually manipulating the windows, moving it up or down to reveal the content of the document. Reveal the content of the document, whereas the second case, the user is manipulating the document, pushing it up or down to reveal is the content through the windows. What is usability principle you use to justify one method over the others? Also consider the case when you want to scroll from the side to side as well as up and down. What implementation consideration are important? Answer. There are many usability principles which can be brought to bear on the examination of the scrolling principle. For example, observability. The whole reason why scrolling is used is because there is too much information to present all at once. Providing a mean viewing document content without changing the content increase the observability of the system. Scroll bar also increase observability because they help to indicate the wider context of the information which is currently visible, typically by showing where the windows of the information fits within the whole document. Wherever observability does not address the particular design option for the fourth order here. Predictability. The value of the scrolling mechanism lies in the user being able to know where the particular scrolling action will lead in the document. The use of arrow on the scroll bar are used to help the user predict the effect of the scrolling operation. If an arrow points up, the question is whether that indicated the direction the window is being moved, the first case, or the direction the actual text will have to move, the second case. The empirical question here is to what object do user associated the arrow, the text, or the text window. The arrow of the scroll bar is more closely connected to the boundary of the text windows. So the more usual interpretation would be to have it indicate the direction of the window movement. Synthesizability. You might think that it does not matter which object the user associated to the arrow. They will just have to learn the mapping and the life with it. In this case, how easy it is to learn the mapping? Can the user synthesize the meaning of the scrolling action from the change made at the symbol and the display? Usually, the movement of the box within the scroll bar itself will indicate the result of the scrolling operation. Familiarity or usability. It would be interesting experiment to see whether there was a difference in the performance of the new user for the different scrolling mechanism. This might be the subject of the more extended exercise. Task components. There are some implementation limitations for the scrolling mechanism see below. In the light of the limitation, does the particular scrolling task prefer one over the other? In considering this principle, we need to know what the kind of the scrolling activity will be necessary. Is the document a long text that will be browsed from the end to end? It is possibly a map, a picture with is a single slightly large than the actual screen, so scrolling will only be done in a small increment. Some implementation consideration: what the scrolling mechanism does to toolkit provide. It is easy to access the two options discussed about within the same toolkit. In the case of the second scrolling option, there are enough key of the mouse to allow this operation without interfering with other important mouse operations, such as arbitrarily moving in the insertion point, or selecting a portion of text, or selecting a graphical item. In the second option, the user places the mouse on a specific location with the window and gesture to dictate the movement of the underlying document. What kind of behavior is expected when the mouse hits the boundary of the window? Is the scrolling limited in this case to step bounds in the size by size of the window? So the scrolling between two distant points requires many separate smaller scrolling actions. Chapter 11: Evaluation Technique. Exercise 11.1. In the group or pair, use the cognitive walkthrough example and what you know about user psychology. See Chapter 1 to discuss the design of the computer application of your choice, for example, a word processor or a drawing package. Here, focus your discussion on the one or two specific tasks within the application. Answer: this exercise is intended to give the student a feeling for using the technique of the cognitive walkthrough (CW). CW is described in the detail in the chapter, and the same format can be used here. It is important to focus on the task that is not too trivial. For example, creating a style in a WP package. Also assume a user who is familiar with the notion of style and with application on the same platform. Make PCs unique actors, but not with the particular word processing package. Attention should be given to instances where the interface fails to support the user in resolving the goal and where it presents false avenues. Exercise 11.2. Design an experiment to test whether adding color coding to an interface will improve accuracy. Answer: the following is only an example of the type of experiment that might be devised. Subject taken from user population. Hypothesis: color coding will make selection more accurate for IV independent variable color coding. DV dependent variable accuracy measured as number of error. Design between group to ensure no transfer of learning, or within group with appropriate safeguard if subjects are scarce. Tasks: the interface are identical in each of conditions except that in the second color is added to indicate related menu item. Subject is presented with a screen of menu choice. Order randomly and verbally told what they have to select. Selection must be done with a strict time limit when the screen clears. Failure to select the correct item is deemed an error. Each presentation place item is in a new position. Subject perform in one of the two conditions. Analysis test. Exercise 11.3. You have been asked to compare user performance and preference with two different learning systems, one using Hypermedia C Chapter 15, the other sequentially listen. Design a questionnaire to find out what the user think of the system. How would you go about comparing user performance with these two systems? Assume that all users have used both systems. Questionnaire. Consider the following question in the design the questionnaire. What information is required? How is the questionnaire to be analyzed? You are particularly interested in the user preference, so questions should focus on the different aspects of the system and try to measure level of satisfaction. The use of scale will make response for each system easier to compare. Table 11.x1 show an example questionnaire. To test perform, you will design an experience where two groups of subjects learn the same material using the two systems and test how well they have learned using standard measurable tests. Part 1. Repeat each system. For each system, indicate your agreement or disagreement with the following statement. 1 indicated complete disagreement and 5 complete agreement. The system tell me what you do, what to do at every point. Disagree. 1, 2, 3, 4, 5. Agree. Too easy to cover from a mistake. Disagree. 1, 2, 3, 4, 5. Agree. Is easily to help to get help when I needed. Disagree. 1, 2, 3, 4, 5. Agree. I always know what the system is doing. Disagree. 1, 2, 3, 4, 5. Agree. I always know where I am in the training material. Disagree. 1, 2, 3, 4, 5. Agree. I have learned the material while using the system. Disagree. 1, 2, 3, 4, 5. Agree. I could have learned the material more effectively using a book. Disagree. 1, 2, 3, 4, 5. Agree. I always know how well I'm doing. Disagree. 1, 2, 3, 4, 5. Agree. Part 2. Comparing both the system. Which system choose one was most helpful? A. B. Effective. A. B. Usable. E. B. Please add any comment you have about either system. Subject user group. IV. Style of the learning system. DV. Perform measure as the test score. Design between group design. Exercise 11.4. What are the benefits and problems of using video in experimentation? If you have access to video record attempt to transcribe a piece of action and conversation, it does not have to be experiment. So opera will do. What the problem did you encounter? Answer. The benefit of video include accurate realistic representation of task performance, especially where more than one video is used. A permanent record of the observed behavior. The disadvantages include vast amount of data which are difficult to analyze effectively, transcription, obtrusiveness, special equipment required. The student can try transcribing a video record conversation from a TV soap will do. The aim to get the student to experience some of the difficult of representing a visual record in the semi-formal written format. The student should discuss which part of the video are most difficult to represent and how important these parts are to understanding the clip. Exercise 11.5. In section 11.5.1, we saw that the observed result could be the result of the interference. Can you think of alternative design that may make this less likely? Remember that the individual variation was very high, so you must retain and within group design, but you may perform more tests on each subject. Answer. The students should read carefully the description of the experiment in the section 11.5.1 to look for a way of reducing the possible interface. Three possibilities are: during the initial training period, swap back and forth between learning the two sets of icons with the aim of the getting the subject used to swapping between the two sets of the remembering icon. However, the design could be argued to suffer of the same flaw as the original. If the abstract icon had been taught in isolation, perhaps they might have fared far better. One could invent a tree set of random icons, call them R. We could then interpose them in the experiment that is present the icon in the order RARN and RNRA. The intention is to swap any transfer effect in the noise of the random icon. It could be argued that our experiment then measured the robustness of the icon set to such noise. We could give the subject multiple representation, for example, in NAN and NANA presentation order. This would not remove transfer effect, but does give us some way to qualify them. Imagine that in the A and AN group that the second representation of the abstract icon was significantly worse than the first, but there was not similar effect for natural icon in the NANA group. This would both give us positive evidence of the transfer effect and perhaps give us some quantitative measure. However, even going from this additional evidence to a strong conclusion will be difficult. Notice that all the above measures require additional subject time and one has to constantly wake up and the advantage of the rich experiment against those of large subject group.